Hello, everyone. So, as you can see, today we're going over something called biconditional statements. This is just an extension of the conditional statements we learned about in the last video. So, let's start with the basic definition. So, a biconditional statement is the conjunction. It's the conjunction of the conditional and its converse. So there should be a lot of terms that you're familiar with. Conjunction means like an and, joined with the word and. The converse is the reversal of your conditional. So your conditional is if P then Q. The converse is if Q then P. We could see symbolically, we have P with the arrow to the Q. That just means P if P then Q. And then the conjunction symbol, that like up arrow, and then the inverse converse symbol if Q then P. But there's a way to abbreviate this. Most people simply will write it out like this. You have P and then an arrow pointing both directions and then a Q. Because when we think of biconditionals, we think of them in terms of like a forward direction and a backward direction when we're writing out these types of statements. And we'll see what that is when we get to an example. So when we have this, the arrow going in both directions, we read that as P if and only if Q. So that's how it's literally translated. P if and only if Q. So what does that mean? Well, it kind of helps us understand what we need for a biconditional statement to have truth value. So biconditional statements are true when, and it's a conjunction, so when both the conditional and the converse are true. So just like how conjunctions worked before, both parts need to be true for the entire thing to be true. So let's take a look at the first example. Given the biconditional statement below, write both the conditional and converse. Determine the truth value of the biconditional. Explain why it is true or false. So the conditional is going to be the forward direction, if P then Q. Our statement is two angles are supplementary if and only if the sum of their measures is 180 degrees. So, again, we're just going to break it down. The forward direction is relatively simple. You just start out with if. If, take the hypothesis, your P value. So if two angles are supplementary, if two angles are supplementary, then, and now we'll write out the statement Q, which is the sum of their measures is 180. Then the sum of their measures is 180 degrees. So that's your conditional. And again, this is like the forward direction, because you're just writing it kind of like you're converting it into a simple if-then statement without really changing the flow of how it was originally written. The converse is, now we're going to write it in terms of the backward direction. So if Q, then P. So we say if the, well, let me write it like this. If two angles have a measure of 180 degrees, then the two angles are supplementary. So again, it's just the backward direction of the conditional. So what is the truth value? Well, this is kind of like almost like tautological in that, like, literally supplementary angles are defined as angles that add up to 180. So it's true. There's not a real like nice way to explain it other than like it's literally the definition of supplementary angles. If two angles are supplementary, then their angles will measure, the sum of their measures is 180. There's nothing really crazy to it. Okay, so let's take a look at some more examples. All right, same deal. Write the conditional, the converse, and determine the truth value. So I wear my snow boots if and only if it snows. So the conditional would just be, the forward direction. If I wear my snow boots, then it is snowing. You can see I'm kind of like changing a bit of the grammar up just to try to make more sense. Can be a little flexible when writing it out, but you want to keep the intended meaning the same. So the converse, again, just the opposite direction. So we say if it is snowing, then I am wearing my snow boots. Okay. So, what is the truth value? Well, take a look at each part. If I wear my snow boots, then it is snowing. The original biconditional is just I wear my snow boots if and only if it snows. Like, it's a little weird because this is less like, it's not like a mathematical statement where it's like easily verifiable or whatever, but If we take the statement at its word, like, sure, if the person wears their snow boots, then it must be snowing. If it is snowing, then I am wearing my snow boots. There's situations where that's probably not true because, if you're like asleep at night and it starts snowing, I'm assuming you're not going to sleep with snow boots on, so you wouldn't be wearing your snow boots. So I would declare the truth value as false because the converse can be shown to be false. And this one's a little weird. Normally, you're dealing with like very easily verifiable statements or whatever, but just apply a little bit of like logic, and you can come up with like a reasonable conclusion to that. So that is it for biconditional statements.